Alright guys, this problem is similar to the homework, the pelican problem or the climber problem, but the basic gist is that we have two objects moving at a given time. So in this problem, we have Super Luke holding on to his golf club here. We're going to say that he is ascending, he's flying through the air magically at 20 meters per second. And the question is, if he drops the golf club, I'll put that in air quotes when we talk about that. If he drops the golf club, how far will he be from it at the end of 5 seconds? So how far between after 5 seconds? Okay. We talked a little of this in class, well, this year, maybe not next year, so let's just say we haven't done this. If you have two separate objects, you must treat them as two individual set of variables. In this case, Luke, so let's make a category for Luke, is traveling upwards at a constant velocity, which means we can just do 3 variables as opposed to the standard 5. You're welcome to do the standard 5, but VI would be 20, VF would be 20, and acceleration would be 0, and all 3 of those say the same thing. So here we have that he's going to travel in a, oops, almost screwed up. This will say the initial spot of both of them is 0, and up is positive. Okay? And according to this right here, he's going to travel for 5 seconds. Now, a picture in this case is particularly valuable because, let's go ahead and remove this or put it elsewhere real quick. Let's just actually put it over here. Okay. A picture in this case can be extraordinarily helpful to try to get an idea of where these objects are doing. So in this case, we have Luke is going to be going upwards. And the golf club is a little bit tricky, okay? The golf club is actually going to go up. I thought that was going to dot. Okay? Golf club is actually going to go up for a little bit and then come back down. And we'll talk about why I know that here in just a second and how you can handle that. But we have everything we need. If we wanted to find the displacement of Luke, this is going to be the easiest thing ever, but we'll come back to that in just a second. I'm going to fill out the rest of the stuff. What about for the golf club? Well, the golf club is going to accelerate. Since Luke dropped it, we're going to go ahead and say it's going according to gravity. So it's not a bad idea, by the way, to put subscripts where necessary. So this is the displacement of Luke, and this is the displacement of golf club. The times should, in fact, be exactly the same. Acceleration is negative g, because gravity is going down. Here's the mistake that people make, and this is why there's an air quotes over here on drops. I said drops, so a lot of people want to put a 0 right here. Except here's the deal. When I say drops it, usually if a person is standing still, then yeah, you can make that assumption. Except Luke is already moving at 20 meters per second. This would be like if I'm traveling in a car at 60 miles an hour and I drop out of the vehicle onto the ground, and of course start spinning, and I'm sad. All right. How fast was I initially going? Not 0. I was initially going 60 miles an hour. So how fast is that golf club going initially? It's going at a positive 20 meters per second. All right. So now we can easily measure the displacement of Luke. The displacement of Luke is simply going to be velocity times time, which is going to be 20 meters per second times 5 seconds. He's going to go up in the air about 100 meters, a little bit more than a football field. Excuse me. And then how do we get g here? Well, that's simply going to be this equation right here. And this is simple plug and chug. We already have displacement, so this would be 20 meters per second. Let's move it just a little bit more. Times 5 seconds plus 1/2 times negative g times 5 seconds squared. And the final answer on that should be negative, I'm going to flip to the next page, you're going to see what kind of prediction is going to go on there, negative 22.5. So, what is the answer? Well, come back to the picture. This displacement of Luke is 100 meters. And then this I should do a different color here. Let's go ahead and go peach. This will be the displacement of the golf club, and that is the negative 22.5 meters. I said negative 22, didn't I? Yep, negative 22.5. Okay, so again, we have to be smarter than the math here and recognize what we really want. Well, we want the distance between them from here to here. So I'm basically just going to get 100 plus 22.5. It should be 122.5 meters. Okay. Now, what math did I use to do that? Honestly, really what I did is I paid no attention to the negative. Why is that okay here, Spain? Now, isn't that magic math? Well, the question in the table is how far are they from each other, which are distances. So this distance is 100 meters. This distance is 22.5, and I can clearly see from my picture that I need to add both of them. So that's where I get my 122.5. Sure, you could do the math to take 100 meters minus a negative 22.5, but the minus, like, I don't entirely know how to explain why that should be there, other than it should cancel because we really should be doing positive, because really these are distances. Honestly, I would even say probably better math to understand is the fact that these are distances. So this is the distance of Luke plus the distance of the golf club. So it should just be add the distance, 22.5 meters, which would be your best one. But again, honestly, if you just came up with the final answer here, that's good. I do want to show you one more thing. Okay, over here on the right side, using this equation for the golf club, I don't know why I put a G there, for the golf club, displacement of golf club is VI times delta t plus 1/2 a delta t squared. One thing I did want to show you is that over time, what some of these answers actually are. Meaning, I'm going to plug in the same numbers. The initial velocity is 20, but time is going to change 1, 2, 1, 2, 3, 4, and 5 seconds. Plus 1/2 times negative g times time squared. Okay, and the answers are over there on the right side. I've already done the calculation for you. Now, thing to note that people kind of struggle with is, does it automatically go down? No, it doesn't automatically go down. As a matter of fact, at the very beginning, as we've already said it, it's traveling upwards. And so actually, the very beginning here, in the first second, let's go back to that peach example right here, okay? There would be your displacement of the golf club. After the first second, Luke would only go 20 meters, because he's going 20 meters a second. So after the first second, they'd only be separated by 4.9 meters, because the golf club is still going up. Okay. Actually, after 2 seconds, the golf club is still going up, which you can see the fact that it is still positive 20 after that. But of course, the Luke has gone another 20 meters for a total of 40. And since it's slowly accelerating down, this didn't go that much further. As a matter of fact, you should be able to look at these numbers and realize that in about 2 seconds, or specifically about 2.04 seconds, this will be at its top. And these numbers over here are in fact displacements. They're not adding on top of each other. They're talking about relative to 0. So here, when you see 15.9, that's actually not adding to the original. It's saying this is 15.9 above the original. So compared to this guy right here, you can see that it is now going down. After about 4 seconds, it's almost exactly back where it began. So you see that now, after 4 seconds, there's our arrow. So we are now headed downward, but displacement is always the arrow from the initial to the final. And then it's not till the end that we get that displacement of the golf club being negative 22.5, like we saw in the previous problem. Hopefully this is helpful. If you have any more questions, just let me know.